Assalamualaikum and greetings. As you can see, we have four members that made up as a team named Absolute Zero, and our motto is Next Newton in the Making. For our topic, we choose Absolute Zero since our group name itself is Absolute Zero. What is Absolute Zero? Absolute zero is the lowest possible temperature when nothing could be colder and no heat energy remains in a substance. Absolute zero is the point at which the fundamental particles of nature have minimal vibrational motion, retaining only quantum mechanical, zero-point energy-induced particle motion. How it's measured? Absolute zero temperature is conventionally measured in Kelvins, Celsius scale increments, and Rankine scale Fahrenheit scale increments with increasing rarity. Absolute temperature measurement is uniquely determined by a multiplicative constant, which specifies the size of the degree. The most transparent definition of this standard comes from the Maxwell-Boltzmann distribution. All of these define the relative numbers of particles in a system as the decreasing exponential functions of energy at the particle level over kT, with K representing the Boltzmann constant and T representing the temperature observed at the macroscopic level. Why is it impossible to reach absolute zero? Firstly, getting down to absolute zero requires extracting an infinite amount of heat, which is impossible, although it is possible to reach temperature close to it through the use of cryocoolers, dilution refrigerators, and nuclear adiabatic demagnetization. The use of laser cooling has produced a temperature less than a billionth of a Kelvin, and to study such phenomena, scientists have worked to obtain even lower temperatures. For the current research on getting down to 0K, in September 2014, scientists in the Cuore collaboration at the Laboratory Nazionale del Gran Sasso in Italy cooled a copper vessel with a volume of 1 cubic meter to 0.006 kelvins for 15 days, setting a record for the lowest temperature in the known universe over such a large contiguous volume. And in June 2015, experimental physicists at Massachusetts Institute of Technology (MIT) have successfully cooled molecules in the gas of sodium-potassium to a temperature of 500 nanokelvins. By cooling these molecules a bit further, it is expected to exhibit an exotic state of matter. What kind of exotic? Scientists have achieved temperatures extremely close to absolute zero, where matter exhibits quantum effects such as superconductivity and superfluidity. For superconductivity, it is actually a phenomenon of exactly zero electrical resistance and expulsion of magnetic fields occurring in certain materials. And for superfluidity, it is a state of matter in which the matter behaves like a fluid with zero viscosity. And this is how superconductivity and superfluidity looks like. On the left above, it is the Mayer effect that results from the superconductivity. And for the superfluidity, as long as this actually comes from experiment using liquid helium, where at first it will bubble up and the bubble will be gone and it will be a liquid. And as long as it remains superfluid, the liquid, it will creeps up the wall of the cup as a thin film, and it comes out on the outside. This is our prediction of what will happen at absolute zero based on our research and assumption. At first, atoms would stop moving because atoms will occupy the lowest energy state. Since it has the lowest energy state, it would stop moving. And gases seem to contract indefinitely as temperature decreases, and also another gas at constant pressure will reach zero volume at what is now called the absolute zero of temperature. This is a volume versus temperature and a pressure versus temperature graph, and each graph will have an x-intercept of -273 degrees Celsius. And that is all from our group.